Hi, I'm Gordon Wright from Mason Technology. Today I want to talk to you about optics and the terminology used in the modern day optics on a microscope. I have in front of me an Olympus BX53, and here I have a range of optics, and I want to talk about the grades, the color coding, numerical aperture and resolution, etc. The first thing I'm going to cover is the colors of the objectives. So we can see here the 4x has red, the 10x is yellow, 20x is green, 40x is blue, and the 100x objective is white. This is common across all microscope manufacturers and is a useful guide for the user so they can clearly see the magnification they are on at the time. Here we have three 40x objectives. A PlanAchromatic objective, which has correction for 2 colors of light, PlanFluorite, which has correction for 2.5 colors of light, and PlanApochromat, which is corrected for 3 colors of light. The other important point to note between these objectives is the numerical aperture. So on the PlanAchromat it has the lowest numerical aperture of 0.65. This allows the users more depth of field and is very useful for screening applications where the user wants to focus less and get through their samples a lot quicker. As we move up to the PlanFluorite, we have a 0.75, and then the PlanApochromat has 0.95. So the PlanApochromat is corrected for 3 colors of light and has the best resolving power, but that also means the least depth of focus, so more focusing is required. The other symbol that's on all of these 3 objectives is the infinity symbol. This shows us we're using an infinity corrected optical system on the microscope. This allows us to add additional ergonomic features and phototubes into the microscope system. All of these objectives have a maximum field number, can be used for fields of view of up to 26.5 millimeters. The PlanAchromat lens can only be used for a field number of 22. It's clearly written on the objectives where 26.5 is written on it. This is the maximum field number it can achieve. Where nothing is written on the objective, 22 millimeters is the maximum. If we look at the eyepieces now set behind, we can see we have a 26.5 and we have a 22 millimeter field of view eyepiece. So the 22 millimeter field of view eyepiece should be used with the PlanAchromat 40, and the 22 or the 26 can be used with all other objectives. Here we have 3 different objectives: an PlanApo 100x oil, a UPlanXApo 40x oil, and a UPlanXApo 40x dry lens. These all differ in relation to the Coverslip correction. So the PlanApo 100x oil has a 0 indicated. This indicates that it's designed for looking at the surface of your specimen. So for example, in microbiology, if you don't use a Coverslip, this would be the recommended objective. The UPlanXApo, it has 0.17 written on it. This relates to the Coverslip thickness, which is standard at 170 microns. So this objective would have to be used to get the maximum resolution with a Coverslip mounted onto the specimen. We see the UPlanXApo Dry lens, and this has a correction color on it. Because this is a dry lens, it's important that it's corrected optically for the Coverslip thickness. And due to modern manufacturing techniques and also irregularity in mounting mediums, this is adjustable so that we can now go from 0.11 to 0.23 millimeters. The other interesting point here is between the 40x UPlanXApo Dry and the 40x UPlanXApo Oil is the numerical aperture. So the dry lens has 0.95, which is the maximum can be achieved with the dry lens. The 40x Oil Apo lens has a numerical aperture of 1.4, which gives a superior resolution. So I'd like to review the 40x objective. I've put this now on the microscope. This is the 40x objective with the correction collar, and I now want to show you how this is used properly. We often get calls from customers who are having problems with image quality, and it usually is related to the 40x correction collar. So we can clearly see here it's set at the moment for 0.17 millimeters, and this is the normal Coverslip thickness that we would use on a specimen. However, sometimes they're thinner. So if I go down to 0.14, I can just have a little look and see does that improve it. If it does improve it, then we can try going down a little bit further. And if that improves it more, you keep going until you get to the optimal position. If, however, it's the opposite and it gets worse, go back to your 0.17 and then start to move upwards. So now we're looking for, take our Coverslip. And keep doing that until you get to the optimal position. This would be one of the more common reasons a customer might call. For example, they may have set this to 0.11, which is the lower limit. And now I'm looking down the microscope and I see a really fuzzy image. So always start at 0.17. Focus on your specimen. Try going up, try going down, and refocusing. And once you have that right, you should get the optimal position for your objective. So I hope that was useful. If you would like any more hints and tips on microscopes in terms of optics or color illumination or many other videos we have online, please check out our website, or you can look out for posts on our LinkedIn page.